For those who are new, this series uses www.falstad.com for circuit simulations. Hey everyone! Today, we're diving into the voltage divider part of the Falstad series. As the name suggests, this circuit is all about splitting voltage, but how exactly does it work? Well, as you probably know, a resistor limits the current flowing through a circuit. In a series circuit, the current stays the same, so the voltage gets divided across the resistors. Let's take a closer look. Actually, even if you're not familiar with electronics, you can still make a good guess about the voltages in this simple circuit. So, what happens if we make some changes? Let's do this. We will randomly change the values of the resistors. Logic can help us here. For example, the voltages at parallel points are the same. That means each branch has 10 volt. But how is it divided? If the total resistance in this part is 44 kilo with 10 volt across it, let's calculate the voltage across the 26 kilo resistor. It's approximately 5.909 volt. Now let's move on to the second part. Here, the total voltage is still 10 volt, and the total resistance is 119 kilo ohm. But there's an important detail we must keep in mind. The sum of all resistances from this node to ground is 102 kilo ohm. We will base our calculations on this. If we understand the rule, we can quickly calculate the voltages across each resistor using the formula. For the first point, the voltage is 8.571 volt. At the second point, the total resistance is 78 kilo ohm and the voltage is approximately 6.55 volt. At the third point, the resistance is 45 kilo ohm and the voltage is 3.872 volt. Now we come to the main question. What is the voltage at this resistor? If you have some electronics knowledge, you can find the potential difference from the diagram. But in real life, voltages are never marked like this on a circuit. So let's get back to reality and remove these indicators. If we want to find the voltage at any point, we need the current. And if we know the voltage and resistance, there's no problem calculating it. For the first section, the total resistance is 44 kilo ohm and the voltage is 10 volt. So the current is 227.27 microampere. We calculate the second section in the same way. Current is 84.03 microampere. The total current flowing through the circuit is therefore approximately 311.3 microampere. Now that we know everything, we can calculate the voltage across each resistor. Let's get started. Resistor 18 kilo ohm voltage is 4.091 volt. Resistor 26 kilo ohm voltage is 5.909 volt. Resistor 17 kilo ohm voltage is 1.429 volt. Resistor 24 kilo ohm voltage is 2.017 volt. Resistor 33 kilo ohm voltage is 2.773 volt. Resistor 45 kilo ohm voltage is 3.782 volt. We've reached the end of this calculation-heavy video. If you found it helpful, check out our other videos too. Subscribe for more electronics tutorials and click the bell. Bye.